Here we are going to look at a classic book published in 1890s, specifically 1893 by Cambridge at the University Press, written by S.L. Loney. We are going to take a question number 11 from exercises 34, heights and distances. Okay, let's look at the question. A, B and C are three consecutive milestones. That means between A, B and C, 1 mile. A, B, C, so they are milestones. So each point is 1 mile away. On a straight road from each of which a distant spire is visible. So they can see a spire from each of these points. The spire is observed to bear northeast at A. So what are the directions that we normally know? We know north, we know south, we know east, we know west. So it says the spire is observed to bear northeast at A. That means northeast is this direction, northeast direction at A. East at B. So if you look from B, it is at east. So this is the east direction. And 60 degrees east of south at C. 60 degrees east of south. So from south, if you go towards east, so 60 degrees east of south means something like this, 6 degrees. East of south, south, east of south. Okay, so to draw this specifically ABC, let's try to draw a picture. And actually, finally, we have to prove that the shortest distance of the spire from the road is this value in miles. Let's try to sketch a simple figure here. So let's take the spire is somewhere here. So we take it as P. And then where should be the point A? So it says that point A, if you observe from point A, the spire is at northeast. That means if this is A, the spire is here, northeast. That means we can draw a line from spire like this, and on top of this line somewhere here, point A will lie. That means if you look at from A, spire is at northeast. Okay, and from line point B, it is east. That means point B, it is east. That means point B should be somewhere here. East is there. So that means this way. So the spire should be here. Point B should be there. Obviously, what we can do is we can drop a line here on this line, and if you extend A up here this way, that means this point will be point B. We look at from point B, P is at east. So like this, point A, P is at east. Okay, so again go forward, 60 degrees east of south at C. East of south means from south, if you go to east 60 degrees, you will see the spire. That means from point C, if this is the point C, you have the south, which is going down like this. And from south, east of south means from south, go 60 degrees east of south, you should see the spire. That means if you draw a line from here to spire, that is the line of 60 degrees. This angle is 60 degrees. Correct? Interesting, isn't it? So that means again, this distance equal to this distance. AB is equal to BC is equal to 1 mile. This is given. And so other things, if you draw a horizontal, basically something parallel to PB and then perpendicular to that line, that is the south line, So this angle is 90 degrees and this angle is 45 degrees, isn't it? This is actually 45 degrees here, northeast. So and this are parallel, therefore this angle is also 45 degrees, correct? And now what we have to find is prove that the shortest distance of the spire from road is this much. The road is A, B, C. Shortest distance, to find shortest distance, you have to drop a perpendicular to the road. You have to drop a perpendicular to the road from P. So this is the perpendicular. Let's take it as Q. So we need to find this one is equal to PQ. We need to find PQ. Okay. So this is the pictorial diagram. So let's see some angles that are unknown and try to link this question. And one more thing, we can extend this line up to here. And this is a right angle triangle. This angle is 60, therefore this angle is 30 degrees, correct? Because the right angle triangle, 60 plus 30 is 90. And there are a few angles that we need to find. This angle, and which is this angle, which is equal to 180 minus alpha, because this is a line. On the line you have alpha, 180 minus alpha, the other one. And we say this angle, let's take this one, is beta. And we have another angle here, which is equal to gamma. So we need to find some things. So yeah, we need to find PQ. What exactly PQ is? PQ can be written as PQ is equal to CP sine gamma. If you find CP, then sine gamma is equal to PQ. So we can aim to find gamma, we can aim to find CP, then we can find PQ, which is the one that we need to prove. So what can we do? So let's try the angle gamma. Angle gamma plus 180 minus alpha is plus 30 from a triangle CBP triangle. This is from CBP triangle. So we get this is equal to 180 degrees, correct? So when you add all three angles of a triangle, it should be equal to 180 degrees. Therefore, gamma is equal to alpha minus 30 degrees. Gamma is equal to alpha minus 30 degrees. Also, we can write an equation for beta. Beta plus 30 plus 45 plus gamma equal to 180 degrees, which is coming from CAP triangle. CAP triangle. So this will give us the angle for beta equal to 180 minus 75 minus gamma. So gamma is equal to, this is alpha minus 30, so this is 180 minus 75 minus alpha plus 30. So we have beta, which is equal to 135 minus alpha. We have two equations, one for gamma, other one for beta, correct? Okay, so now we need to relate this to distances. So from sine theory, CP divided by this angle of this sine of this angle is equal to BC divided by sine of this angle. Okay, so we can say CP over sine of 180 minus alpha is equal to CB divided by sine of 30, this angle here. So also we know CB is equal to 1, therefore CP is equal to Sine 180 minus alpha is sine alpha. Sine 30 is half. That means sine alpha divided by half, which is equal to 2 sine alpha. First equation. So we found Cp in terms of alpha. Also, we can write an equation for Cp using CPA triangle. In that case, Cp over sine beta is equal to AC over sine 30 plus 45. This large angle here, 30 plus 45. So that gives us another equation for Cp. Therefore, Cp is equal to AC in this case equal to 2 miles, ABBC, AC equal to 2 miles. So it is 2 sine beta. Beta is equal to 135 minus alpha divided by sine 75. Now we have something with alpha as well as sine 75. Sine 75 can be found. Sine 75 is equal to sine 30 plus 45, which is equal to sine 30 cos 45 plus cos 30 sine 45. So we can simplify this one, and if you say sine 30 is half over root 2, 1 over 2 root 2 plus root 3 by 2 and times 1 over root 2. So which will give us 2 root 2 upon 1 plus root 3. This is sine 45. This is sine 75. Okay. So we have few equations. Now let's go to the next page. We'll take them to the next page where we found Cp is equal to sine alpha. Let's write it here. Cp is equal to 2 sine alpha, and Cp is equal to, the other equation is Cp equal to 2 sine 135 minus alpha divided by sine 75. 2 sine 135 minus alpha divided by sine 75, and we found sine 75 to be equal to sine 75 is equal to, we found it equal to 1 plus root 3 divided by 2 root 2. 1 plus root 3 divided by 2 root 2. So we can substitute them here. 2 times 2 root 2 divided by 1 plus root 3 is sine 135 cos alpha minus. Okay, let's translate these three values that we got here. 1, 2 and then 3 is the value for sine 75. So let's write these three equations in the next page. First one is Cp equal to 2 sine alpha. Cp is equal to 2 sine alpha. The other one what we got was Cp equal to 2 sine 135 minus alpha over sine 75. Cp equal to 2 sine 135 minus alpha divided by sine 75, and sine 75 is equal to, we got sine 75 is equal to 1 plus root 3 over 2 root 2. 1 plus root 3 over 2 root 2. So what we got, equation 1 is the one, this one, this equation 2, and this equation 3. So our aim here is to simplify these equations and find alpha, because what we need is gamma. So yeah, let's write that one also. What we are aiming is to get PQ is equal to Cp sine gamma. So what we need is PQ is equal to Cp sine gamma. But gamma is equal to, we got it from here, alpha minus 30. That means which is equal to Cp sine alpha minus 30. That means if we find alpha, from these three equations we can substitute here, and then we need to find Cp. Cp is equal to 2 sine alpha, so that means we can substitute Cp. Cp is equal to 2 sine alpha from this equation. That means 2 sine alpha times sine alpha minus 30 is the one that we need to find. So what we need first is to find alpha. So from 1, 2 and 3, 1, 2 and 3, we can write 2 sine alpha is equal to 2 sine, so we can expand this one, 135 cos alpha minus cos 135 sine alpha divided by sine 75. Okay, so here we can either take sine 75 to the other side, and actually this 2 will cancel off. So we have sine alpha times sine 75 is equal to sine 135 equal to 1 over root 2 times cos alpha minus cos 135 means minus 1 over root 2, therefore this will become plus 1 over root 2 sine alpha. This equation, if you look at carefully, we can actually find tan alpha, divide whole thing by cos alpha. We can see tan alpha times sine 75 is equal to 1 over root 2 plus 1 over root 2 tan alpha. Okay, so 1 over root 2. So take the tan alpha one side, tan alpha sine 75 minus 1 over root 2 is equal to 1 over root 2. The rest is simplification. So let's try to put the value for sine 75. Sine 75 equal to 1 plus root 3 over 2 root 2. So this means tan alpha 1 plus root 3 over 2 root 2 minus 1 over root 2 is equal to 1 over root 2. So this one actually root 2 root 2 is the common term, so 2 root 2 go up, therefore tan alpha is equal to 2 root 2 divided by root 2. Here 1 plus root 3 minus 2, correct? Because this is root 2, so 2 will come here, 2. So that will simplify and give us tan alpha is equal to 2 over root 3 minus 1. Tan alpha equal to 2 over root 3 minus 1. So once you know tan alpha, we can write sine and cos alpha, so we can use the Pythagoras theorem here. So this is 2 root 3 minus 1. So this hypotenuse equal to 2 squared 4 plus root 3 minus 1 squared square root. Okay, so we leave it like that. So therefore we can find PQ. PQ is equal to 2 sine alpha cos 30 minus cos alpha sine 30. So basically we know the values of this one. So cos 30 is root 3 by 2. So 2 times root 3 by 2 sine squared alpha minus 2 times sine alpha cos alpha sine 30 is half. So this 2 cancel off, this 2 cancel off, which is equal to root 3 sine squared alpha minus sine alpha cos alpha. Okay. So now it's a matter of substituting for sine alpha. Sine alpha is equal to sine squared alpha equal to 2 times 2 4 divided by 4 plus root 3 minus 1 whole squared minus sine alpha is 2 over, so this sine alpha and cos alpha, there are two terms, 4 square root of 4 plus root 3 minus 1 the full square times again square root, therefore we get 4 plus root 3 minus 1 squared and then 2 times cos alpha is equal to root 3 minus 1. So if you simplify the denominator, 4 plus 3 minus 2 root 3 plus 1 is the denominator. Numerator is 4 root 3 minus 2 root 3 plus 2. So we get 2 root 3 plus 2 divided by 7, 8 minus 2 root 3. We can divide by 2 root 3 plus 1 divided by 4 minus root 3. Multiply by 4 plus root 3 to make this one a real number. So what you get here is that 4 root 3 plus 4 plus 3 plus root 3 divided by 16 minus 3 is 13. So that's the getting the answer there, 13, and 4 root 3 and 5 root 3 is 4 plus 3 is 7, 7 plus 5 root 3. So this is the answer. This is the shortest distance. So please check the answer for which is given in the question. 7 plus 5 root 3, 7 plus 5 root 3 over 13, which is the shortest distance. So answer is correct. So let's give credit to the author. Original author is S.L. Loney, who published this book in 1893 under the Cambridge at the University Press with the book title Plain Trigonometry. Thank you very much. I think you should be able to follow the steps. Main idea is to visualize the question. Please try to visualize the picture here and try to get the angles correct with alpha, gamma, and beta. So try to write these equations using sine rule and then this equation. So using those two equations we can get rid of unknowns and also there is angle 75, sine 75. You can use the expansion theorem to find the angle 75. And then once you have this intact, using these three formulae, you will be able to get rid of all the other unknowns and find tan alpha. This is very important in your theory. So once you get this tan alpha, and then go to this definition that we found, that Cp is equal to PQ is the shortest distance equal to Cp sine gamma. So if you look at again, Cp sine gamma is the shortest distance equals to Qp. So if I just take a different color, it's this distance, the shortest distance. This is Cp. So Cp sine gamma will give the shortest distance. So very important. So this is the shortest distance. So please try to write this equation and expand that equation, and you should be able to get this equation. This is another equation that you should see whether you got it. And once you get this equation, it's a matter of substitution for sine squared alpha and sine alpha cos alpha, and the denominator will cancel off, and then finally you will be able to get the answer. So the final answer is this one, shortest distance. Thank you.